Hey everybody, this is Alex Merced and you're listening to another episode of Datanation. And in this video I want to just talk a little bit about streaming and why creating real-time data can be tricky. Okay, so oftentimes when you are data engineering, so again, data engineering, you're figuring out how to get the data from operational systems to analytical systems in a way that's sort of easy to use for the data analyst and the data scientist. That's the job. That's the mission. Okay, and there's a lot of challenges in that because basically, ideal world, the data in your analytical systems is in sync with your operational systems. But again, how often does the data in your operational system change? Constantly, right? People are creating new accounts, doing new transactions, all these kinds of things. In ideal world, real time, that would also become available for your analytics. But that's not necessarily very easy to do. Traditionally, what you would do is you would do what's called batch processing. So there'd be some level of acceptable latency that you would agree upon, saying, okay, hey, I'm okay with only having data up until the last week. Okay, so then what would happen is at the end of the week, you would take all the data that was generated that week in your operational systems and then update your analytical systems and run those processes then. Optimize. And the great thing about batch processing is that you can kind of, since you have a big chunk of data, you can really kind of deliver that data in a very optimal way, in optimal sized files and partitioned nicely, sorted, all sorts of really good stuff. Okay, but again, the idea behind batch processing is that there's these defined beginning and endpoints. So basically, you run this job this workload once a week or once a day. Or even, let's say, once an hour. Okay? And again, the more frequently you do it, then the more fresher the data, but then the more optimization challenges there are. Because you're dealing with smaller amounts of data, and so you might, do batch ingestion once an hour, but then do a optimization every day or something like that. So you'll just go back and re-optimize that data at the end of the day for all those days' writes. So that's all fine and good. Okay. Now, if you're doing true real-time streaming, so that means data is going to come in generally as it goes. So this is typically going to have to there has to be some sort of mechanism for the individual thing that just got added to be tracked, delivered, and ingested as it goes, meanwhile trying to kind of do it in the most optimal way possible, because you're not going to necessarily have time to be doing all these sort of optimization type jobs continuously, or you have to kind of think it through. So let's kind of explore that. And again, nothing I'm saying here is necessarily the end all be all, because your particular use case might have specific nuances that you have to think about. But oftentimes, this is going to look something like you're going to generally have a Kafka cluster. So if you're not familiar with Apache Kafka, it's essentially a pub-sub messaging broker. Now, what does that mean? It means anything can send it a message, and anything can receive messages. Those messages are generally categorized into different topics. Okay? Now, why would you want to use a messaging broker? Because you might have a lot of systems that need the same information. So let's say without a messaging broker, I might let's say have 3 databases that I use operationally, and let's say I create a user account. Okay, I might have a situation where basically I create a user account. I now need to send this information to all 3 of these databases to create maybe a slightly different entry in each one, because they track different things for different purposes. But I got to establish all those connections one-on-one, and then basically if I have another application that needs to interact with those databases, I need to kind of separately create these kind of interactions. So basically you end up creating all these sort of, imagine that telephone operator who's plugging little cables in the holes and whatnot. It's just all these cables going all over the place. So wouldn't it be nice if there was just basically one person that everyone exchanged this data through? That's essentially what Kafka does. So in that case, instead of me directly going to go create an entry in the database or handling sort of the creation of the customer account, I might get the information for the customer account. There might be a topic in the Kafka cluster called new customer account, and there's going to be different services that have something to do with new customer accounts. So each of those services can independently head over to the Kafka server and say, hey, I want to see, hey, are there any new customers? And each of them can independently handle sort of their part of the flow. So in this case, they're not like locked up by each other. They're not dependent on each other. And then sort of the flow, they're not. Each of these applications are more isolated from each other, and it becomes easy to deliver the same information to multiple places. So wonderful. So if someone creates a new account, okay, my operational databases, those processes will go grab the information from the Kafka topic, but at the same time, my analytical systems can go grab that from the Kafka topic at the same time. So I can be updating my analytical systems simultaneously as updating my operational systems, instead of doing what's traditional, where you update your operational systems and then you take it from your operational systems to your analytical systems. So that's all fun and good. Okay, so then the question just becomes sort of like, how often are you checking, Kafka for those? Are you going to do it continuously, like every few seconds, or even more frequently? And what happens, for example, if you're writing that data, okay, you're generating very small files. So you might be generating a Parquet file with, let's say, like 1 or 2 records, depending on like how many actual new entries there are since the last time you checked. So then there's this big issue of sort of optimizing that data, because then you got all these small files. So then you have to kind of think about, okay, how often am I going to run compaction? And the problem is, if I just sort of run compaction on, I might want to do it like an hour latency, where basically, hey, at the end of this hour, so let's say at 10 a.m., I want to run compaction on all the records generated between 8 and 9 p.m. or something like that. So that way, I'm not colliding with any kind of concurrent jobs, but at the same time, I'm still optimizing. I'm running optimization jobs that should be able to run parallel to the writes that are coming in. Okay. And trying to find other ways to sort of manage that to minimize any latency when you're scanning through a lot of small files, because streaming can very much create the small files problem. But at the same time, you can, there's also like other approaches where there's like different like streaming databases where, they'll pull that data and then just kind of hold it in memory. So you could have something like, if you really want to, you might have a system that is really for that real-time visibility that might just actually hold records in memory or something like that. So you'll have this process that's ingesting data into your data lakehouse, into physical files and optimizing those files, but it's still not necessarily your real-time service. So you might have another service that pulls in the Kafka. You might just literally query it directly from a service like something like Flink. Or you might, pull it into some server that holds it inside like a Redis memory store. Okay, maybe it only holds that day's records, so that way you can create a system that can really quickly query at least that day's records to give, let's say people really want that sort of level of visibility. This could be really useful for something for like stock data, where you're really trying to monitor like the movement of that day's stock prices. Okay, you have this other system that's just kind of holding that day's information in memory as it comes in. So you're not necessarily reading a bunch of small files, it's in memory, so it can be accessed pretty quickly. But again, that system is separate than, but it's all grabbing it from that same Kafka broker, and that's the beauty of it. Different systems can do different things with the same data. So that way it doesn't become this sort of hopscotch of 1-step to 2-step to 3-step to really get that sort of real-time movement. There's a lot of other things to kind of consider, sort of like, okay, how sort of do you sort the data, like before before you push it to Kafka? Do you sort it when you retrieve it from Kafka? There's all sorts of different steps along the way you may want to think through in order to write data in sort of an optimal way. But again, the trade-off is always latency. Like, okay, hey, does that mean that people are going to only see the data that's like off by a few seconds? Is that acceptable? Okay. And at the end of the day, the question is, do you really need streaming? That's another conversation that's always important to have. Like, a lot of people just say, build real-time data pipelines because they were told to build real-time data. The question is, do you really need real-time data? Because it can be complicated, it can be expensive, it could be done affordably with the right tools. But in the day, what is the purpose of your usage of the data? What is the value of getting that data a little bit fresher, like getting it up to the second? Like, what business value would that provide, other than you feeling good that you have the most recent data? Will it actually able to help you make decisions that would create enough value to justify the cost of having access to that data? So these are generally questions you're going to want to ask ahead of time. Okay, not just say, okay, hey, you told me to build this thing, let's build it. Sit there and say, okay, hey, let's make sure that we are building the right thing, and asking the question like, what is the value? How do we quantify that value? and how do we quantify that cost to see, hey, does this make sense? Okay, so yeah, so those are just some quick thoughts about, thinking through sort of like the differences between streaming and batching, and thinking through architecting a streaming system. This is just sort of me kind of talking off the cuff, so I'm sure there's little things that, nuances I did not capture or could elaborate on, or might be done differently in different situations. But hopefully this gets your brain going and thinking. And again, if you enjoy my podcast, you enjoy the content that I put out there, make sure you're following me on LinkedIn and on Twitter. Just look up on Twitter, it's AM Data Lakehouse. On LinkedIn, just look up my name, Alex Merced. But either way, have a great day. Enjoy. I'll see you all later. I'll make sure I put a link to everything in the video description. See ya.